In this video, we're going to be talking about experiments. Experiments is another form of research that you can do, and there's a lot of definitions here, so I've put them all on the screen to begin with. So there's a lot going on here. It can be very confusing, especially the independent variable, dependent variable, experimental group, control group, but we will go through these and give a few examples so it'll all make sense by the end. Like I talked about in the correlation videos, an experiment is when you vary one or more factors to observe the effect on some behavior or mental process. So you change one variable to see a corresponding change in another variable. This is what you need to do if you want to say there's a cause and effect relationship. Correlations might indicate a possible cause and effect relationship. It's an experiment that will actually tell you, yes, there is. This thing causes that thing. It is a cause and effect relationship. So you have to have two variables. One of those is going to be the independent variable. So the independent variable is the factor that is manipulated. So for example, the main example we'll use, since it's a psychology class, is whether a certain drug alleviates depression. So what I'm going to manipulate is the drug. Do you get the drug? Do you not get the drug? So the independent variable would be the drug. This is what you manipulate. You get to control it. You get to decide if someone gets it or if somebody doesn't get it. Like you decide whether or not they get the drug. You have total control over the independent variable. Whereas the dependent variable, you do not get control over this in the same way. The dependent variable is the factor that is measured. It's what you measure at the end. It's called the dependent variable because it depends on whether or not you got the independent variable. So in my does this drug alleviate depression study, what am I measuring at the end? I'm measuring your depression level. So in that version, the dependent variable would be depression. The easiest way to tell the difference between the independent and the dependent variable is to use the phrase, does blank have an effect on blank? What goes into this first blank is going to be your independent variable, and what goes in the second blank is going to be the dependent variable. So for example, in the version I've been talking about, you're asking, does this drug have an effect on depression? It really doesn't make sense to say it the other way. If you say, does depression have an effect on the drug? What's that mean? It only makes sense to say, does this drug have an effect on your depression levels? So the drug, whatever goes in that blank, that's the independent variable. The dependent variable goes in that last space. Now, whenever you have a study, you have to have an experimental group. The experimental group is the group exposed to the treatment, or the independent variable. In this case, it would be the group that gets the drug. They get the experimental drug. So you have to mess with the experimental group somehow. Sometimes you're also going to have a control group. For the control group, this is the group not exposed to the treatment. So it is a comparison group. In this case, I would need a control group. I can't just give all of my participants a drug and look at their depression afterwards, because who knows, maybe depression just naturally goes away after a while. I'd have to have half of my participants getting the drug and the other half would not get the drug. And then at the end of the study, I would compare the depression levels for the group that got my medication compared to the group that didn't get my medication. And if my medication works, that group would have lower depression levels. So this is an example of a group or of an experiment that needs a control group. Occasionally you have a study that doesn't. This one needs a control group. Now the important thing to keep in mind is that you have to have random assignment for your studies. This means that you are assigning participants to experimental and control groups by chance. So for example, in my medication and depression study, it would not be very legit if I measured everyone's depression at the beginning and talked to them, and the people I thought were kind of on the mend, chances are in 6 months they're not going to be depressed. They go in my experimental group because my experimental group's the group I want to be less depressed at the end. And everyone who I think looks like they're probably going to stay depressed, they go in my control group. That's not a legit study. Everyone has to be randomly assigned to one group or the other. So there are a lot of different ways to do this. You can have the first half go in one group, the second half go in the other. You can have it be every other person. It could be based on what their last names are. Whatever, you just have to randomly assign them for it to be a legit study. Now, sometimes for your control group, there's a chance that just being in the study, just thinking something's going to happen is actually going to affect you. It's kind of like if your kid scrapes his knee and he says, kiss it and make it better, and you kiss it and he's like, oh, it's all better. Your kiss didn't do anything, but his expectations actually had an effect. Your kiss did something because he thought your kiss was going to do something. That's the placebo effect. It's results caused by expectations alone. So in order to account for this, to control for this, to make sure this doesn't affect your results when it shouldn't, sometimes for your control group, you're going to give them a placebo. So a placebo is when you give an inactive substance or condition that is something sometimes given to those in a control group. So, for example, if you're doing a study with medication, oftentimes the placebo is going to be like a sugar pill. There is a study I talk about in General Psychology about using hypnosis to treat PTSD, and the control group came in and heard a lecture on stress once a week. They thought just showing up once a week for a class would have an effect, so half the people showed up and just got some random lecture rather than the group that got hypnotized before therapy. Sometimes you'll put somebody on a wait list, they'll call it, for 6 months while the other half gets an actual therapy. Whatever it is, sometimes you give them something that's really not supposed to do anything because you think their expectations might have an effect. So that's the placebo. And then finally, it's not just the expectations of the participants that have an effect. It can also be the researcher. So in a double-blind procedure, this is going to help control for that. A double-blind procedure is when participants and research staff are ignorant, i.e. blind, about who has received the treatment, that independent variable, or a placebo. So you're not sure who is in the experimental group, who's in the control group. And the reason that you would do this is, one, because of experimenter bias. In experimenter bias, what this is when the experimenter's expectations influence the results unintentionally. They're not trying to screw something up, but just the experimenter's expectations when they're doing the therapy with the experimental group, they might be more enthusiastic. When they're giving the pill to the experimental group, they might, be more positive about, hey, are you feeling better? Even if it's unintentional, it can still bias them. So if the experimenter, if the research staff doesn't know who's in each group, you don't have to worry about that. And then you're also controlling with this for participant bias. So in participant bias, this is when participants' expectations influence results. So it's the participants. If they think they're in the experimental group, it'll have an effect. If they think they're in the control group, it has an effect. So if they don't know, it can't have an effect. And in a double-blind study, both the experimenter and the participant are blind as to who is in the experimental group and who's in the control group. So another example of this final thing, another example for an experiment, see if you can figure out what is going on here. If I have an experiment where I want to see if running 30 minutes a day is going to improve cardiovascular health as compared to not working out, not running. So to tell what is the independent variable and what's the dependent variable, if you can figure these two things out, again, the easiest way, use this phrase. Which way does it make sense? The only way this makes sense is, does running 30 minutes have an effect on cardiovascular health? So we know that the independent variable has to be the running 30 minutes because that comes first, and we know that cardiovascular health is the dependent variable. And so what's the experimental group going to get? The experimental group gets the treatment, which means the experimental group has to run. They have to run the 30 minutes because they are getting screwed with. Now in this version, if you have a group that also is told to just sit on their couch 30 minutes, and that would be the control group. If you just make everyone run for 30 minutes, then there would be no control group. So this is a study where potentially you don't need a control group. Just make everyone run, measure their cardiovascular health at the beginning and then at the end, and you're set. So that would be another example of an experiment. And then you can really say cause and effect. Running does have an effect on your cardiovascular health because you did an experiment to figure it out. And that is everything you need to know for experiments.